picking up where we left off, today we'll be solving simultaneous equations using matrices. We have some steps we need to follow when solving simultaneous equations using matrices. So let's go through a simultaneous equation. If I have 9x plus 4y is equal to 5, and I have 3x minus 8y is equal to 4. As I list the steps, we will be doing the procedure for the steps one time. So the first step is to line up the x's and the y's under each other. Line up all the x's and the y's under each other. And as I list the steps, you all can probably do the steps one time. So on the right hand side, I'll have my 9x plus 4y is equal to 5. And it just so happens that the other equation is already lined up for us. 3x take away 8y is equal to 4. Step 2 is to place all the coefficients of the variables in a matrix in a 2 by 2 matrix. So how we do that, we take the variables and we slap them in our 2 by 2 matrix. So we'll have 9, 4, 3, and negative 8, just as how we see it on top. Followed by a 2 rows, 1 column, a 2 by 1 matrix which has the variables involved in the question. So in this case, the variables involved were x and y, and it's very important to put which variable first. So in this particular example, I had my x variables first, followed by my y variables. So I'll put my x variable first, followed by my y variable. If y was first in the both equations, I'll put y, then x. So that's part of the second step. And the last part of the second step, we place this equal, placed equal to the next 2 by 1 matrix that has the numbers after the equal sign. After the equal sign. So it'll be equal to the 2 by 1 matrix will be 5, 4. Once you establish this point, it's very, very easy to solve them. Step 3. We say this is of the form AX is equal to B, where A, X, and B are all matrices. So we say is of the form AX is equal to B, and we're going to call that equation 1 for further reference. Number 4, we need to calculate A inverse. In the previous video, we calculated the inverse of a matrix, so we'll just be using that knowledge to calculate the inverse of this matrix A. Now in some CXC questions, you will see place the simultaneous equations in the form AX is equal to Y. It's the same procedure. AX and Y are matrices. I can replace A with W. So it would be WX is equal to B. Okay? When you calculate an A inverse, we know that our A inverse is 1 over the determinant of A multiplied by the rearranged A. Well, the determinant of A will be the leading diagonal, which is 9 multiplied by minus 8. Take away the other diagonal, which is 3 multiplied by 4. 9 multiplied by negative 8, that is negative 72. Take away 12. This will give us negative 84. The rearranged A, we must flip the leading diagonal, so the minus 8 comes on top, the 9 goes below, change the signs on the other diagonal, -4 and -3. So A inverse will be 1 over -84, which is the same as -1 over 84, into -8, -4, -3, and 9. This is scalar multiplication. We multiply the number by each of the numbers inside. Remember what I said? Leave it as the denominator as the same thing. Don't simplify it, only if you are getting a whole number. So here we have 8 over 84, because two negatives make a positive, 4 over 84, 3 over 84, and -9 over 84. Step 5. This is a very important step. We must pre-multiply equation 1 by the inverse on both sides. On both sides. Now the word pre gives me an indication that I have to multiply before. Meaning, if I multiply equation 1 by A inverse, I must pre-multiply equation 1, so I will have the A inverse coming first. So it will be A inverse AX is equal to A inverse B. And this is very important. And in a future video, I'll show you all why. From the laws of matrices, A inverse multiplied by A will give me the identity matrix. So this is the identity multiplied by X is A inverse multiplied by B. Again, the identity multiplied by any matrix gives me back the matrix. So this happens every single time we are solving simultaneous equations using matrices. IX becomes X is equal to A inverse multiplied by B. Now it's just a matter of replacing X with what we had it as, XY. A inverse is 8 over 84, 4 over 84, 3 over 84, and -9 over 84, multiplied by the matrix B, which was 5, 4. So the only type of working we have now is to multiply A inverse multiplied by B. So we'll consider in our working column 8 over 84, 4 over 84, 3 over 84, and -9 over 84, multiplied by 5, 4. So let's check. 2 by 2, 2 by 1. Yes, they can be multiplied. And the answer will be a 2 by 1 matrix. 2 rows, 1 column. First row, first column. Second row, first column. So let me explain to you all one time why we pre-multiply. If I had multiplied anyhow I wanted to on both sides of the equal sign by the inverse, and I had B multiplied by A inverse instead of A inverse multiplied by B over here, this will cause problems because B is a 2 by 1 matrix and A is a 2 by 2 matrix. The numbers are not the same in the middle, so we will not be able to multiply them if I had put A inverse after. So back to the question. E11 is the first row, 8 over 84, fix the bracket, 4 over 84 multiplied by the first column, 5, 4. First by first plus second by second, 8 over 84 multiplied by 5 plus 4 over 84 multiplied by 4. And let's work out what this is. 8 over 84 multiplied by 5 plus 4 over 84 multiplied by 4. 2/3. E21 is equal to second row, 3 over 84 minus 9 over 84 multiplied by the first column, which is 5, 4. Again, first by first multiplied by 5 plus second by second minus 9 over 84 multiplied by 4. 3 over 84 multiplied by 5 plus negative 9 over 84 multiplied by 4, negative a quarter. So xy is equal to, I just now worked out what this right hand side is. This right hand side worked out to be 2/3 and negative a quarter. I have a 2 by 1 matrix on the left, I have a 2 by 1 matrix on the right. Both matrices are the same size, and the equal sign states that they are equal to each other, and this happens every single time. So we state the matrices are equal, equate components, or equate corresponding entries. I get x is equal to 2/3, and I get y is equal to negative a quarter, and that's it. So let's double check our work. I'm going to substitute x is 2/3 and y is equal to negative a quarter in both of my equations above. So when x is equal to 2/3, you all can check it over with me. 9 open bracket 2/3 plus 4 open bracket negative a quarter is equal to 5. Double check in both equations, please. 3 into 2/3, take away 8 into negative a quarter, I get 4. So both my solutions worked for both my equations, so I know my question is correct. Let's dive into another example. Let's say we have 4x plus 25 is equal to 11y, and 9x plus 4y is equal to 30. First things first, I do have all my variables lined up under one another. I have my x's lined up, I just need to move across my y and move across 25. So I'll have 4x take away 11y is equal to 25, and I'll have 9x plus 4y is equal to 30. From here, we can form our matrix equation, pull out the coefficients, 4 minus 11, 9 and 4. My x variable came first, followed by my y variable. Xy is equal to 25, 30, or negative 25, 30, because we move the 25 across. We say it is of the form ax is equal to b. Now our job is to calculate A inverse. A inverse is 1 over the determinant of A multiplied by the rearranged A. The determinant of A is my leading diagonal, which is 4 by 4. Take away my other diagonal, which is 9 by minus 11. This is 16. Take away negative 99. 16 plus 99. Check it in the calculator. 115. The rearranged A I must flip my leading diagonal. Well, the numbers are the same, so it really doesn't make a difference. And I have to change the signs on the other diagonal. So that becomes positive 11 and the 9 becomes negative 9. Now I can calculate A inverse. It's 1 over the determinant of A multiplied by 4, 11, minus 9 and 4. We get 4 over 115, 11 over 115, negative 9 over 115, and 4 over 115. Nice. Now we need to say pre-multiply equation 1 by A inverse on both sides. So we pre-multiply equation 1. And remember, if you forget, just come back and say let this be equal to 1. Pre-multiply 1 by A inverse on both sides. So it'll be A inverse multiplied by A multiplied by X is A inverse multiplied by B. Now this is how I want everyone to write out your question and your statements for CSEC. Recall A inverse A is the identity, and the identity multiplied by x will give me back x. So my equation now becomes x is equal to A inverse B. Replace x with our xy. Replace A inverse with the inverse of A, which we worked out as 4 over 115, 11 over 115, minus 9 over 115, and 4 over 115, multiplied by B, minus 2530. If you want to work it out as it stands, you can go ahead and do so. I like to consider to C, my right hand side is equal to E11, E21. So I'm going to consider A inverse by B. 4 over 115, 11 over 115, minus 9 over 115, and 4 over 115, multiplied by negative 2530. We know they can be multiplied by each other to give me E11, E21. E11, first row, 4 over 115, not multiplied yet, 11 over 115 by first column, which is negative 2530. First by first plus second by second. So here we have 4 over 115 multiplied by negative 25 plus 11 over 115 multiplied by 30. We jump on the calculators and check and see what it is. 4 over 115 by negative 25 plus 11 over 115 multiplied by 30. I get 2. E21, second row, first column, minus 9 over 115, 4 over 115, multiplied by negative 25, 30. First by first, minus 9 over 115, multiplied by negative 25, plus second by second, 4 over 115, multiplied by 30. Minus 9 over 115 by negative 25 plus 4 over 115 by 30. Make sure and use your brackets when you're punching these things in your calculators, please. Your brackets make a big difference. I get 3. So I can safely say now that xy is equal to 2, 3. We say that the matrices are equal. Equate corresponding entries. We get x is 2 and y is 3. And again, double check it in our question. So 4x plus 25 is equal to 11y. When I rearranged, I get 4x take away 11y is equal to negative 25. So 4x take away 11y, so that's 4 into 2, take away 11 into 3, I get negative 25. Next one is 9 into 2 plus 4 into 3, I get 30. So my solutions work for both of my simultaneous equations. And that's it. In next video, we will do some CSEC past paper questions. If you learned something new, please leave a like, and I will see you guys next time.